Have your notes pulled up for section 2.2. And I don't know that I'm showing you much new stuff. The new form of the quadratic equation might be new. I really don't know if you did that in Algebra 2 or not, but I do know from Algebra 1 and Algebra 2, you should be pretty familiar with quadratic equations, vocabulary, everything that there is to know, basically, about a quadratic equation. So, quick review. The axis of symmetry is a vertical line that turns your parabola into, that's what makes it symmetric. It's like a fold line. And that line goes through the very important point called the vertex. Now, up until now, we have called this the standard form of a quadratic equation. It's been known to us as standard form. It's what we called it in Algebra 1. I'm pretty sure it's what you called it in Algebra 2. That's what I've always called it until Pre-Cal goes and changes things up. They're giving us a different form, which is fine. I like to call the new form vertex form because what's cool about vertex form is the vertex jumps right out at you. You see what the vertex is right off the bat. You don't have to do any work. This takes some work to find the vertex. So this is called vertex form, aka now all of a sudden Pre-Cal calls it your standard form. So because we don't want to call both of them standard form, we're going to call this one polynomial form. Makes sense, right? It's a polynomial. So this one is standard form or vertex form, and this one is now, we're going to call it polynomial form. So notice that in both forms, the leading coefficient is going to be the same. And I know that you've looked at leading coefficients before to see if your parabola opens up or down, to see how wide or skinny your parabola is. And that's one thing that these two equations have in common, is the A is visible in both equations. For both equations, you can, so like I said, quickly, you can find the vertex. As long as this is a minus, this number right here is the x-coordinate of your vertex. And then whatever this is, if this is plus a k, then your y value is positive. If this is minus k, then your y-coordinate is negative. So that's where your vertex is located. And then your axis of symmetry is always just a vertical line right here. X equals. So vertical line at that x-coordinate. Goes to that x-coordinate. Really easy if you're in vertex form. If you're in polynomial form, you've got some work to do to find your vertex, and this is what you're used to. You've got to do your x equals opposite of b over 2a. Once you get that, that number becomes your x-coordinate. Then, to get your y, you have to take whatever this is and plug it into your function to find your y value. Again, I'll review. I know you know this already. Again, I'll review. Ready? If your leading coefficient is positive, the graph opens up. And think about this. If your graph opens up, your vertex has to be the lowest point. It's a minimum y value. Your vertex is a minimum. If A is negative, then the graph opens down, and then your vertex would be the maximum. It's the highest your parabola will go. It's a maximum. All right. I have a quadratic equation. Notice it's in vertex form, okay? So here's something I want to point out. This is A. This is a minus. This is supposed to be a minus right here. When this is a minus, I literally just grab the number behind it. So I'm going to grab 1. That's going to become my x-coordinate for my vertex. My y-coordinate is whatever this is. So this would be a plus 2. My y-coordinate would be a positive 2. Since this is minus 2, my y-coordinate is negative 2. A is positive. The graph opens up. Since the graph opens up, the vertex is going to be the lowest point. We're calling that a minimum. To find the y-intercept, you know how to do it. Sub in 0, and then you can write your y-intercept like this, or like this, or like this. MyMathLab is usually specific, and it'll tell you if it wants you to write your y-intercept as an ordered pair. Just make sure you follow the directions. The axis of symmetry is always going to be a vertical line right there. Now, I'm going to hold off on domain and range for just a minute because it wants us to graph it. So let's go graph it. Here we go. I took my vertex, 1, -2, and I plotted it in green right there. Then I took my y-intercept. So my y-intercept, it crosses the y-axis at 1. So I put my y-intercept on the y-axis, and then I just made it symmetric. So if this is my vertex and it passes through this point, I know it has to be symmetric like this. So I created my third point and drew my parabola. Now keep in mind, these arrows go up forever and out, left, right, forever. So I think you can easily look at this picture and tell me that the domain is all real numbers. Goes on forever. You can also tell me the domain is all real numbers because there's never a chance of dividing by 0. There's never a chance of square rooting a negative. Okay, so that's how you get your domain. Range I would totally get from the graph. How low does it go? How high does it go? Well, how high does it go? Forever. How low does it go? -2 is as low as it goes. So I'm going to say my range starts at -2 and goes to infinity. This green dot is filled in, so that's going to be a bracket. And then infinity. I can never reach it and put a dot on it. I can always go a little further and a little further. That's why it needs a bracket around it. All right, next one. This time it's in polynomial form. My leading coefficient, A, is -1, therefore it opens downward. Vertex, all day. We've got some work to do on the vertex. This is the little formula to find the equation for your axis of symmetry. So I'm going to, since B is already negative, I need to do the opposite of -2. So I'm going to write +2 all over 2 times A. 2 divided by -2 is -1. Okay, so I know that -1 goes here. And then I need to find this one. So I took my function, where is it? Oh, it's up there at the top. Took my function, sub in -1, sub in -1, sub in -1, do the math. I got +3. And since the parabola opens down, the vertex is going to be a maximum. Y-intercept. Subbed in 0 for x. Got it? Boy, these questions are just all over the place. Axis of symmetry, it's going to be a vertical line right here. Vertical line right there. Axis of symmetry. Oh, look. And then it asks me for domain and range without a picture. You know what I did? I drew a picture. Well, I didn't need a picture for domain. You shouldn't need a picture for domain. It's a quadratic. The domain of a quadratic is always all real numbers. Range, you need a picture. So I just did a real quick sketch. The vertex is at -1,3 and it opens down. So for range, how high does it go? 3. How low does it go? It keeps going. So I'm going to start my range at -infinity, parenthesis, stop it at 3, And since this green point is filled in, I'm going to bracket around the 3. Next, we are finding x-intercepts, so we're plugging in 0 for y. So on this one, I sub in 0 for y, and I notice that I have this quantity squared. So I just got rid of my 2, divided both sides by 3, and to undo this, I square rooted each side. Okay, and by square rooting this side, it eliminates the squared on my quantity, so I just have x minus 5. By square rooting this side, I get the positive version of the square root of the whole thing, and I get the negative version of the square root of the whole thing, and I could have written one big, I just wanted to make sure that you realize that the 2 is in a radical and the 3 is in a radical. If it's one big radical, the 2 is in there, the 3 is in there. So not quite acceptable to leave a radical 3 on the bottom. So I multiply by radical 3 over radical 3. This is what I get. And then solve for x, add 5 to both sides. Don't let this freak you out. Just keep it with this fraction. This is your signage for this fraction. You all know that when you have a negative, you keep your negative with the number that it's on. Well, we're going to keep this symbol with the fraction that it's on. And when I add 5 to both sides, see, stay with it. And I get 2 answers. I get 5 plus all that, and I have 5 minus all that. I have 2 x-intercepts. Should make sense for a quadratic, for a parabola, to have 2 x-intercepts. All right, the next one, I set equal to 0, sub in 0 for y. I personally do not like factoring when my leading coefficient is negative, so I divided everything by -1. And then that's still 0. Opposite, opposite, opposite. And then I tried to factor it. I crossed my fingers and said, please let this be factorable. It wasn't factorable. Bummer. So I did the quadratic formula. Now, you need to have the quadratic formula memorized. Like, we're assuming by this point you've used it so often, you know it. You need to have the quadratic formula memorized. So I used my quadratic formula, simplified under the radical to get 12. This simplifies because it's a 4 and a 3. It's radical 4, radical 3. Radical 4, radical 3. All terms have a 2. So I factored out a 2 and then canceled. Final answer. Again, 2. 2 x-intercepts. -1 plus the square root of that, -1 minus the square root of that. This is a fun one. It says to find the standard form. Now remember, when you hear standard form now, it means vertex form. And let's see. The example in your notes didn't give you vertex form again. Vertex form's already in your notes. Remember? It's up there. I can tell you, when you need vertex form on a test or quiz, it will be given to you on that test or quiz. You don't have to memorize vertex form. So, I wrote it for you. Okay? Now, it tells me that the vertex is at 1, -2. So I'm going to sub in those numbers here and here. See how I did that? Sub in +1 and sub in -2. Now, the only thing that's unfinished, the only thing I can't circle my answer yet, is because of this A right here. I have to find the value of A. The x stays, the y stays. It's good to have the x and the y in your final answer. But you can't have the a in your final answer. So we still have work to do, okay? So we need to figure out what a is. That's why you're given this extra piece of information up here. This point has to work in my equation. So sub it in and make it work. So sub in 3 for x. Sub in 6 for y. And I showed you right there where I did that. Sub in 3 for x, sub in 6 for y. Let's do some math. Multiplication, subtraction. Please excuse my dear Aunt Sally. Multiplication comes before subtraction. Therefore, you undo subtraction. You undo the subtraction by adding 2 before you undo the multiplication. Dividing by 4. A is 2. And then I just did a real quick rewrite. Hey, final answer. Hey, final answer. A goes there, H goes there, K goes there. Circle it. Finished. Okay, last one. You have an equation called cost. Notice they named it C. How nice of them. Cost of manufacturing a product. X stands for basically number of products. Like if we're making, I don't know, it doesn't say how many, it doesn't say what we're making. If we're making, I don't know, tires. X would be how many tires we're making each day, okay? So this is the equation. Notice it's quadratic. Notice the leading coefficient is positive. So the parabola opens up. It asks, how many units, tires, whatever, X. Find X. So that cost is minimized. All it's asking is to find X in your vertex. See? At that vertex, you have that minimum value. Find X. Right there. We have a formula that does it for us. I subbed in my numbers. There you go. If I produce 35 whatevers, I've minimized cost for that day. All right. That's got it.